Hi folks, welcome to Lecture 7 Part 2, where we'll be talking about hierarchical task analysis. It's one particular method of task analysis. So here's some things to know about the hierarchical task analysis is that it's extremely flexible and adaptable. It's adaptable to almost any situation or task or even any domain. It's considered to be a top-down and breadth-first approach. And this ensures that critical tasks are not overlooked. Okay, so that means that you start off from the top and start at a higher goal, and then you break that down into smaller and smaller and smaller goals as you go along. So you identify the purposes and the goals of the task analysis. For example, the goal of your task analysis might be for training, or in most of my work, it might be for developing good performance measures. But in the example for training, you might want to train someone on how to use the system. So to know what steps to train someone on, you would need to do some sort of task analysis. It might also be used for interface design. If it's a system that's might be poorly done, you might want to use a task analysis to help you decide where those problems are. After doing this, you can redesign the system after you have that collected information. And one of the important things is that goals drive all the subsequent decisions on your task analysis. So whatever your goal is for conducting this task analysis, that's going to guide all your decisions regarding that task analysis. And we'll get into that a little bit in more detail. So first, let's talk some terminology, right? Let's make sure that we understand this. So what's a goal? A goal is some external task, such as producing a letter or making coffee. The device is going to be the method, tool, or technique appropriate for achieving those goals. So this might be your laptop or your keyboard or even a mouse. The task or the activities necessary to achieve the goals using whatever device. Subtasks are the components of these tasks, so they kind of make up the task. And the actions are very simple tasks with almost no control structure. So the method is the plan, is what we call it, or kind of the number of tasks or actions linked in some sort of sequence. So you'll see if we have any programmers in the class, the method or the plan is something like if-then logic or loop logic, things like that. So just as an example for boiling water, if the pot is boiling, if the water in the pot is boiling, then turn off the stove, right? So that's kind of a conditional statement. So at the highest level, we have the goal, and you're going to complete tasks that are necessary to achieve these goals. Below these tasks are the subtasks or the components. The actions will probably be included in those tasks as well. And the method is pretty much the structure or the order or the sequence of tasks that you've outlined. Okay. So let's talk about how we use behavioral verbs. We have actions. So for example, turn on, monitor, or press a button. And in this case, monitor is the verb, so to look at something, to continually check something, not the noun like a computer monitor. Equipment acted upon, or the equipment that will be acted on, might include something like a switch, a keyboard, or some sort of display. The consequence of that action should also be described, and you often talk about the feedback resulting from the task performance. And of course, you'll have some criterion of task accomplishment. So how do you know you've completed this task or this task analysis? So were they successful? Yes or no? This is often categorized as a success or a fail. Did they complete the task or not? Later we'll get into whether we can classify these as partial successes or partial failures. We'll talk about that. So for example, you can give something like a rating of a 1 or a 0 or a half. So 0 means a failure or no success. 1 is a success, but maybe something happened along the way, so we give them half a point or something like that. So let's talk about what the hierarchical hierarchical task analysis is and what it does. What it can produce is a graphical representation of a task, and we'll see that with some things called flow maps. It decomposes high-level tasks into constituent smaller subtasks, operations, and plans. And it sometimes uses structured chart notation. It doesn't need to, but it's very helpful that it does, because then we stay structured. What are the steps involved? First, we identify the task goals and the criterion measures, how we know if a goal is being met. This is the very first thing we do. The criterion part of it is what we just got into when we mentioned successes and failures. Here we're asking, how do we know if the goal is being met? That's part of the criterion measures. You can also add performance measures like time on task. How long did it take them to achieve their goal or to accomplish this task? We could look at another performance measure, accuracy. Let's say we have a multiple choice test. How accurate were the responses? In this first step of the HTA, you consider the entire system. Remember, this is the breadth first part of it. So at this stage, you also consider the performance outcomes. So you want to ask some questions like, what objective evidence will show that this goal has been attained? What are the consequences of failure to attain the goal? You want to identify all the human kind of interactions or within the system, but also all the humans that are interacting with the system. Most of the time nowadays, we're not talking about an individual kind of working in isolation. A lot of the times we have very complex work made up of or being done by a group or a team of people. So you want to identify all the humans that might be interacting in that system. So just like in the critical incident technique, you're first identifying the user and the goals, or what the users do with the system. Alright, so then we go ahead and collect data and create a draft decomposition diagram. So this is kind of relates what operators do, why they do it, and the consequences of not doing it correctly. You can also kind of identify significant operations in light of those goals. So here we determine if a goal is being met. If the goal is being met, then no further analysis is required. And this is here the goals of the task analysis itself, not the goals that the user might have within that task. Okay, so just to make that distinction, this is for the goals of the overall analysis. So if the goal is being met, then we don't need to further analyze this task. However, if a goal is not being met, you should either suggest a solution, or you might even decide to decompose the tasks further and get a more granular kind of level. By doing this, you should ideally be getting at where the problem really is, and then you could generate maybe a test hypothesis for solving those performance problems. Okay, this is part of the HTA that's a little bit more abstract. The whole part about identifying significant operations in light of goals and observations and testing hypotheses, this, we're not going to get too much into. We're going to get more into how do we conduct a task, HTA. Now, when generating the hierarchy itself, remember we have an inverted tree here, and we'll show you a picture of what that looks like later. You want to think about which display you ultimately want to choose. So you identify which tasks you're going to analyze, you identify the major tasks to be analyzed, like I mentioned. You're going to break down the major task into subtasks. You're going to determine what subtasks must be accomplished in order to perform the main task or the main goal. And here you can refer to various sources. So you can either look at direct observations, you can conduct interviews, you can look at documentation, and you want to try to be specific about the terms of the subtask. You want them to be relevant to the user group you're talking to. So for the HTA, you're really thinking about actions. Not that much focus is paid to the thought process involved in completing some tasks necessarily. This is what we call actionable items. And you can, though, add cognitive aspects to an HTA. It's definitely possible. Okay, so it's not just only about tasks, but it is a major component of that. Is what are the steps in doing that task? So when we generate the hierarchy, we decide the level of detail that we want to go into to further decompose the subtasks. And remember, sit tight. We're going to be getting into some of the stopping rules pretty soon. So you continue to decompose the process while keeping the decompositions and the numbering consistent. Show you a picture of that in a bit. And then you can group some of the subtasks if they're too detailed into higher level subtasks. So this is all about how we organize these steps. Like I mentioned, usually we want to go breadth first and then get very detailed as we go in to the subtasks. So general rules for doing a hierarchical task analysis. Let's get into those stopping rules that I mentioned a couple of times so far. These are the main rules that you have to abide by. The lower level goals should be logical expansions of higher goals. So this just means that you'll never have a lower level rule sitting on top of a higher level rule. So the higher level goal goes at the top and the lower level rule goes underneath. An example of that is like, let's say the task is making a cup of coffee. Well, you'll always have to boil water before you can make a cup of coffee if you're making a hot coffee. So boiling water is never gonna be a higher goal than making the coffee itself. Okay. So these lower goals have to be extensions of the higher goals. Okay, they have to be, the higher goals get broken down into those small ones. So if you were to hypothetically put those smaller goals together, they would make the higher level goal. So you want to look for clusters of operations that logically belong together under the same goal. Okay, and even if our goal is to, like, let's say boil water, you're not gonna have something like grab a pencil somewhere in there. Okay, there's no reason for having a pencil in there. It's not very logical. You'll probably have items related to grabbing or pouring water, such as grabbing a kettle or things like that. So that's what I mean. They should all be logically structured. Another rule: there should be at least 2, and general rule, no more than 8 sub goals under each higher level goal. Okay, and this is kind of important to keep in mind. If you can only include one subtask under a goal, then that's where you stop, basically. Alright, you should never have only one sub goal with a higher level goal. This is what I just mentioned. Also, this next point is very important for human factors professionals. You will never be able to write the analysis perfectly the first time. That just doesn't happen. Writing up a hierarchical task analysis takes a lot of practice. So you want to lay out the sub goals and the sub goals, and then see if any regrouping or reorganizing is required. Sometimes you might incorrectly categorize subtasks under the wrong goal. So this is where it's very helpful to get the subject matter expert or the user feedback into that task analysis. Okay, so this is what we mean by an inverted tree. This is an HTA example for borrowing a book. So basically an upside down tree. You have the tree trunk, which would be the 0 level goal or the top level goal, borrow a book from the library. And then if you were to just kind of imagine flipping a tree upside down, you have all these branches of smaller tasks and subtasks, or goals and sub-goals. Okay, so it's very abstract when we're just talking about it with a visual. So let's just go through this example. Let's say you want to borrow a book from the library. Your higher level goal then is to borrow a book from the library. So that's your top level goal. In order to do that, there are tasks that are required to complete that goal. So for one, you're going to have to go to the library, right? 2, you're going to find the book that you require. 3, you're going to have to retrieve it from the shelf. And then 4, before you can take that book home and borrow it, you're going to have to take that book to the counter to check it out. Okay, these are the tasks that you need to complete to borrow a book from the library. These 4 tasks. 1, 2, 3, 4. Now, the reason for why we have those numbered is because that's the sequence that the tasks have to be completed in. You first go to the library. You secondly find the required book. Third step is retrieve it from the bookshelf. And fourth, you take the book to the counter. You kind of can't do those out of that sequence. So these numbers are added as annotations to help you determine what order, or what we call the method or the plan, you need to use to accomplish this goal. So and you can see the plan on here. So it says right underneath, borrow a book from the library. The plan is 0, or the plan for the goal of 0, which is borrowing a book from the library, is to do 1, then 3, then 4. If a book isn't on the shelf that you expected, then you can do 2, then 3, then 4. So the plan gives you the order in which to do these steps, and it doesn't necessarily have to be in order. Like I mentioned, there's a lot of loop logic. So you can have something like keep looking until you find the book. So that's kind of looping. You're looking and looking and looking and looking until you meet some condition. Or you could have conditional logic. If you find the book, then move on to the counter to check it out. Okay. And let's take a look at step 2 here, finding the book required. In order to accomplish this task, you have to complete all of the subtasks. So step 2 has subtasks. So to find the required book, you have to access the catalog. You have to access the search screen, enter the search criteria, identify the required book, and then finally note the location. All of these things need to be done for you, or need to be done in order for you to go find that required book. Okay, so that's just one example. Let's take a look at another. Let's say that you want to write a letter. Your goal is to write a letter, so it's at the very top. The tasks that need to be done to accomplish this goal include getting supplies, writing the actual letter, preparing the envelope, and preparing to mail it. So let's break down prepare envelope. What do you need to do in order to prepare an envelope? The steps needed to do this include getting the address and applying the stamp. And we can actually decompose these even further for like getting the address. So to do this, you might find the address book and then find the address. And of course, we can break that down even further, finding the address book. And so this is a very crude breakdown, but you can see that I can definitely go into a lot of detail for such a simple task, such as writing a letter. Keep in mind that the process can go arbitrarily deep. You can go extremely detailed. But you want to stop when the information is no longer useful. There might be no added benefit to breaking things down any further. But of course, if this is a crucial task that someone who has never performed this task might need to succeed at doing it, that missing subtask or component might not lead them to the success. Okay, so you might want to go into more detail for that case. I see a lot of detail in task analyses that are done for training purposes. So for training purposes, you're almost assuming that your user is brand new and doesn't have much experience, if any experience, with whatever it is that the task that you're analyzing. So in those sort of situations, you might want to go into a lot of detail. Okay, so at the beginning of the lecture, we talked about how everyone does task analysis, but how no one can agree on how to do it. Along the same line of thinking, a goal may be met by completing tasks in different sequences. Your task analysis might look different from another person's task analysis, and that might be perfectly fine. The way that John writes a letter, for example, is as follows. So, he gets an envelope, paper, pencil, stamp. He writes the letter, addresses the envelope, applies the stamp. puts the letter in the envelope, and then seals the envelope. Jill, however, does this differently. She gets all of her materials, but first she addresses the envelope. Then she writes the letter and applies a stamp only right before sealing the letter. So another person might have a completely different way of mailing a letter, and that's completely okay. We might achieve the same goal. Sometimes the way that we do things matters, but sometimes it might not. Okay, so it's okay if task analyses are different, but you just have to be careful that they're different. They're not kind of causing anything negative by being different. Alright, now a task analysis can be done any number of ways. Your situation or the task that you're looking at might dictate how you present your task analysis. So when you write up a HTA report, you want to do the following. You want to first state the purpose of the task analysis. Are you looking to train someone on the system or product? Are you looking to redesign the interface? You might be trying to accomplish one or the other. Then state the assumptions made about the task performance. So this is based on the purpose of the analysis. So are you going to include things like the time of day or the working conditions? Now, when I say assumptions, this is getting at potentially how efficient someone is going to be at completing some task. An assumption, for example, might be how much light someone has when they're operating a device or product. Your task analysis might only be applicable when there are good lighting conditions, because the interface might not be visible under any other conditions. So remember, tasks have constraints and resources, and these are all assumptions. This is where those assumptions come into play. So like I mentioned, for example, time of day or working conditions, oftentimes scenarios are developed to help elucidate those constraints and resources. Then you want to format the task description, and that can be done in anything like an outline, so these are usually numbered, a flow chart, which I mentioned earlier, and we'll show you what that looks like again. We already saw a couple examples. You could also have a hierarchical diagram or a table format. And finally, recommendations or analyses are usually in table format are usually accompanied by some sort of task description. Okay, so how exactly do we write those task statements in a task analysis? In one of the previous slides, you saw something like grab pencil and paper. So usually you want to use very simple statements. Your statements should have simple verbs, so you want object and objective statements. For example, heat water until it boils. You might even be inclined to drop the it, so heat water until boil. Each task statement should be distinct from one another. So for each task statement, you should be able to determine when the goal is met and whether performance is satisfactory. So let's think about let's think about the statement heat water until boils. That's straightforward. Has it boiled? No. Okay. The condition has not been satisfied. You can usually assign a success or failure to each task. And you also want to identify any special conditions under which that specific task will be performed. Alright? So here's an example. Let's walk through this. Let's say that you're making a cup of instant coffee. Okay? So the purpose of the task analysis is to determine if task performance of time or the task how long it takes to complete this task can be reduced. Right? So maybe that'll help you sleep in a little longer. So here we're looking at training, right? We want to improve someone's performance on some task. There are a few assumptions that we might have, or we can ask the question, what is going to affect how fast it's going to take to accomplish this task? So here are some of the assumptions that we have. Users know how to make the coffee. User is making a cup of instant coffee in his or her own kitchen. So that implies that they know where everything is and that they have access to everything. The coffee pot is clean, operational, and all ingredients are available. All ingredients are stored in a cupboard or refrigerator. Coffee maker is located near the only outlet in the kitchen. The coffee cup is clean. These are all assumptions that we're making about this task analysis. Okay, now we have the scenario. The scenario is the setting for the task analysis. So we can say something like the user is at home and it is early in the morning. The user wants to have coffee before going to work or class, but has limited time to get ready and leave for work. Okay, so these are all your starting conditions, your constraints and resources. So let's decompose this task or goal. The top level goal is to make a cup of coffee as quickly as possible without sacrificing quality. The sub goals to accomplish this higher level goal are to 1. Boil water, 2. Add ingredients to a cup, and 3. Add boiling water to a cup. And we can actually decompose these a bit further. So let's go ahead and do that. Okay. Now your overall goal is to make a cup of coffee. That's still the same, but you have other goals now. Your goals are to boil the water, to add ingredients to the cup, and add boiling water to the cup. So in order to boil water, you want to fill the kettle, you want to heat the water, right? To add ingredients to a cup, you want to add the coffee or the sugar and cream, and then you add the boiling water to cup. Okay, can you decompose add boiling water to cup? Probably, but the question is the question that you want to ask yourselves is, would it be of any use to decompose it any further? That's why there's nothing underneath that step. This kind of stands alone. It's self-evident. You're just adding water, or adding the boiling water to the cup. Other steps, though, you could probably decompose even further. So for boiled water, under fill kettle with water, we can have remove the lid, put kettle under faucet and fill it, turn the tap on, turn the tap off, and you can also decompose heat water. Heat water, you want to turn the heat on, turn heat off when it's boiling. So again, you want to decompose it as far as you can and as far as necessary. Okay, so we can go even further, decompose the subtask of add ingredients to a cup. So we can have add ingredients to cup, such as add coffee. That could include extract a spoonful of coffee from jar, add spoonful of coffee to the cup, and so on and so forth. Okay, so I'm sure you get the picture. You can break each of these down into smaller and smaller subtasks. Okay, so let's move on to discussing the different formats for hierarchical task analysis. This is the outline format here. So we have our goal listed at the top, and then we proceed down the list to kind of list all of our sub-level goals or sub-level goals and so on and so forth. Here, everything is numbered except for the goal itself. A lot of people, including myself, we use 0 for the goal, but it's more intuitive for people to read the goal. So I've done both. It works either way. This here's a flowchart format for HTA. So on the far left, here we have the overall goal, make a cup of instant coffee. And then we have our sub goals to the right of that, and then from them branch the subcomponents. Notice that here they're still numbered. Numbering is going to be very key no matter what format you choose to display your hierarchical task analysis. This is a hierarchical flowchart format for the HTA. Most people prefer this flowchart format. People kind of prefer this inverted tree look over the other methods. It kind of clearly indicates that the goal is at the top and that the sub-level goals are underneath. So if you complete all the sub-level goals, you're going to accomplish that top-level goal. So the sequencing information also follows how we would typically process information from left to right and top to bottom, right? Once again, the numbers are still there and your plans are still there, your methods. So for boil water, you have do all in sequence 1 through 2. So that's telling you to, for boil water, you want to fill a kettle and you want to heat the water. Okay. And finally, we have the table format. And a lot of people's opinion, this is probably their least favorite format. It's kind of difficult to follow and it doesn't show you that nice hierarchy very well. But of course you can still use it, and for some it's their go-to format. It's actually kind of helpful to use this because uh, this works very well for the analysis part of the job. So on the last two right columns of the table, you have the analysis part. The conclusions that you're drawing and the recommendations that you're making based on the analysis of the tasks that are being conducted. So even though it's not very popular and maybe doesn't look very good, it's still pretty helpful. But whatever format you choose is fine. So as long as you provide some justification for it and you make it work, you make it easy to read. Alright, so we're back to the stopping rule. We're going to dive a little further into these rules. So you want to stop when you have all the information needed to meet the purposes of the analysis. So some say analyze or decompose until P times C is sufficiently low, where P is the probability of error or not meeting the goal, and C is the cost of not meeting the goal. This doesn't tell you much in layman's terms. So what it kind of means is if a goal is not being met, you determine the operations necessary to achieve the goal, and you refine the goal into subordinate goals, right? So really these are just kind of heuristics more than hard and fast rules. There's a lot of contention on how to stop or how to know when to stop or stop decomposition and stop going into further and deeper steps. You can kind of tell once you get into the groove of it. You have your overall goal, and at some points it just starts getting a little ridiculous. So like, let's say your task is to type an email. You're not going to go so far as to say lift index finger up, move index finger over to letter H, move index finger down to press key H. You're probably not going to go into that level of detail unless you're doing something like the key level model or keystroke level model, which is a type of task analysis that we'll talk about next time. But you might not need to go to that level of detail. Okay, so just use your best judgment. Once you see that you kind of have the information as detailed as you need it to be, then you can go ahead and stop decomposition. Like with all our methods, HTA has limitations. One is that strict adherence to any formal method can be time-consuming and very expensive. And on top of that, there's disagreement over what a formal method is or what the rules are. And it's also kind of difficult to get agreement on the taxonomy of tasks. So someone might consider something a higher level goal while someone else might see it as a subtask. And further, too much attention to existing task procedures may limit novel design solutions. So this is kind of like in a lot of industries, such as the petrochemical industry, we have just tons and tons of procedures, hundreds if not thousands and thousands of procedures. Oftentimes those procedures are on emergency situations. Me personally, I do a lot of task analysis on emergency situations. So when I have any SMEs in the room with me conducting these, they'll bring along the procedures that already exist for that specific situation or that specific task. Now this is helpful because they can reference it whenever they need to if they can't remember how to do something, even though they're supposed to be experts. At the same time, we have to be very careful because they might over rely on those materials. They might just end up copying the whole procedure, and then there's no value in that. There's no ingenuity, there's no novelty in that for potential solutions to some of the problems that they've been facing. Okay, so sometimes formal task analysis is just simply not needed. Sometimes you just can go out and talk to someone real quick and ask them like, hey, how do you do this? And that might be good enough. You never know. It depends on the task. It's also very difficult to assess the reliability and validity of a formal task analysis. And why is that? Well, it's because everyone does it differently. Again, the results of a task analysis might differ from person to person. One person might say that 5 tasks are necessary to meet a goal, while another says that 20 are needed. There's a lot of disagreement in that sense. Okay. So what that means is that in practice, the complete HTA process is usually very rarely followed. Now I'm referring to the complete HTA. And remember that I said earlier that task analysis is performed by at least 80% of human factors professionals. So the full and complete HTA might never be done. Generally, the focus is top down and breadth first description. And typically, these tasks are broken down until the human factors person usually runs out of time, or the answer that is sought after, or the purpose of the analysis is accomplished. But like I mentioned, usually we just keep going until we run out of time. It's very hard to do these task analyses and very quickly. Okay, so that just about covers what we're gonna what we need for HTA, or the hierarchical task analysis. We're gonna move on into cognitive task analysis in the next part of the lecture. All right, so stick around.